This is Algebra 2, Unit 3, Lesson 4 on linear modeling. Now, back in Algebra 1, we learned about linear modeling. And so we're going to review that quickly and because that is the first basic kind of modeling that we looked at. So linear functions model any process that has a constant rate. So one variable changes with respect to the other. And remember, the constant rate is actually the constant slope. So constant is the same thing. The function will increase or decrease by the same amount when you are adding. So let's take a look at an example of linear modeling. First of all, usually when we see linear modeling, it's in the form of a linear equation, which is y equals mx plus b. And when we're talking about this, we know that m is going to be the slope, or the rate of change, and then b is going to be your y-intercept, or your starting value. So that should be your view. So let's try this. Dia was driving away from New York City at a constant speed of 58 miles per hour. He started 45 miles away. Write a linear function that gives Dia's distance d from New York City as a function of the number of hours h he has been driving. So our input is h, you put in the hours, and the output is d, which is the miles away from New York City. Okay, so if we have trying to figure out Dia's distance, is going to be d equals. All right, so what is your starting value? He started 45 miles away. So that means that 45 is going to be your y-intercept. That's going to be your b. Now, it says driving away from New York City, and you're looking for the distance to New York City. So the speed is 58 miles per hour. So that's going to be your rate of change. So for every hour that you travel, you're going to be going 58 miles. So h, you plug in h, is whatever your h value is, and multiply it by 58. So this would be 58h plus 45. This shouldn't be new to you, so hopefully this looks familiar. All right, so now that we have this function, if Dia's destination is 270 miles away from New York City, algebraically determine to the nearest tenth of an hour how long it will take Dia to reach its destination. Well, if it's 270 miles, and according to this function, that is a measure of distance. So that should go in for D. So it would be 270 is equal to 58h plus 45. And let's solve it for h, or for D, excuse me, for h. Subtract the 45. You get 225. And then divide by 58. And h actually works out to be, to the nearest tenth, approximately 3.9 hours. So he is traveling at a constant rate of 58 miles per hour. So that means after approximately 3.9 hours, he will be 270 miles away. Now, from that exercise that we just did, we knew the slope and the y-intercept, so it was pretty easy to figure out. Most of the time we do know that, but not always. But sometimes we may know a slope and a point, and we can use the point-slope form of the line. Now remember, the point-slope form of the line is what we used in geometry. It was y minus y1 equals m times x minus x1. Remember, in this form, that m is actually the slope, and x1, y1 is a given point. So it's just some random point that we have, and we can write the equation from that. It can be converted into y equals mx plus b form if we want to. All right, so let's look at an example that has this. Edelyn is trying to model her cell phone plan. She knows that she has a fixed cost per month, so that tells us it's going to be linear, along with a 15-cent charge per call that she makes. So, in her last month's bill, she was charged $12.80 for making 52 calls. So let's create a linear model in point-slope form. For the amount Edelyn must pay, P, per month, given the number of phone calls she makes, C. So the input will be C, the output will be P. So X will be C and Y will be P. All right, now in point-slope form, we need a slope and we need a point. All right, so the slope in this case, the linear model will be, M will be 0.15. Okay, because that's her charge per call that she makes. So what she's charged is based on that. So the fixed cost per month is also, we have to take into account. All right, now, that's really what we don't know. So we don't know where she started, but we know her last month bill, she was charged $12.80 for making 52 calls. All right, so the number of phone calls is 52. So that's going to be her X1, your X1, Y1 when we do this. All right, so that's going, or in this case, it's going to be C, comma, P. All right, it would be 52 calls, cost $12.80. So that's your point, basically, when you do this. All right, so in Y minus Y1 equals M times X minus X1 form, point slope form, Y minus Y1 equals M times X minus X1. We are going to plug in C and P for X and Y instead of that. All right, so using the values here, the Y value would be the P value. The M is 0.15, and the X value is the C value. All right, now, when we plug in the point, it goes with C and P. So in this case, X and Y will be C and P. So this is going to be P minus 1280 is equal to 0.15 times C minus 52. And there we go. Now, if you want, you can solve this as Y equals MX plus B by just distribute through and then solve for P. Or in this case, it'd be P equals MC plus B. But it works. You can leave it in this form. It's just fine. Okay. All right. So how much is Edelin's fixed cost? Well, that would be the y-intercept. So let's solve this. We have P minus 1280 is equal to 0.15 C, and distribute through here, minus 7.8. And then move the 1280 over. And we get P is equal to 0.15 C plus $5. Now that's in Y equals MX plus B, or slope-intercept form. So what's your y-intercept? It's going to be this value right here. This is going to be the y-intercept, or the starting value. So remember, you can use point slope to convert into slope-intercept, and then you can find your value. So your fixed cost on this problem is going to be $5. So that's point slope form, using that, and then we can convert that into slope-intercept form. Now, a lot of times linear models are constructed and we want to work with them. So a lot of times they can be really messy, so we can use the calculator to plot and investigate their behavior pretty easily. So let's look at this exercise. A factory produces widgets, which are generic objects of no particular use. The cost C in dollars to produce W widgets is given by the equation C equals 0.18 W plus 20.64. Each widget sells for 26 cents. Thus, the revenue gained R from selling these widgets is given by R equals 0.26 W. Okay, now we are going to graph each of these on the graphing calculator. Now, for some reason, my axes have disappeared here, so let me draw in my axes that you already have there. So here are my axes, and this is going to be dollars, and this is going to be the number of widgets, which is down here. Okay, now it says, use your graphing calculator to sketch and label each of these linear functions for the interval between 0 to 100 for the W. So the widgets is going to be from 0 to 500. 0 here, 500 here. Okay, and then we want to figure out what our scale is going to be. All right, so let's enter our values. All right, so in Y1, we are going to put the C value, which is 0.18 W plus 20.64. All right, and then in Y2, we're going to put the other one, which is 0.26 W. So I'm going to go to my calculator and plug those in Y1 and Y2. So Y1 is 0.18. I'm going to use the X for the W, plus 20.64. And then 0.26 W for the other one is 0.26X. There's my two equations. All right, now it said to use the W's, or the X's, from 0 to 500. So I'm going to go to my window, and I'm going to adjust it. My X min is going to be 0. My Y min is going to be 500. All right, so that gets my room there. Okay, now I need to figure out my y scale. All right, I need to know how far they go up. Now, if I know I want to go up to 500, I need to figure out what values of y it's going to have. Now, if I go to my table right now, I would have to scroll an awful long way to figure out where 500 is, wouldn't I? So why don't we adjust the table so that we can see a different scale? So let me go to my table set, press the blue second key, the window key. All right, I'm going to start my table at 0. All right, and then delta table. What would be a good one to use? Why don't we use going by hundreds? Because we know we give us a quick overview of where to go. So let's go 100. And now let's look at our table. Okay, so that gives me a pretty good perspective of how big my scale should be. All right, so for my y's here, if I've got to go up to 500, my highest y that I have is 110. So that's how far I got to go. So what would be a good scale to use? Well, this one would be 110. This one actually be 130. So that would be the highest I'd have to go. So why don't we go 150 for our scale? Okay, so if I go to my scale here, I'm going to go from 0 to 150. Okay, so this one will be the blue one. This one will be the red one on the calculator. So all I have to do is graph it. Press the graph key. Whoops, I just screwed that up. I forgot to change my y's. All right, my window, change my y's. Make sure you do the scale first. I forgot to do that. I wrote it down. I didn't do it in the calculator. 0, and we decided it was going to be 150. That's better. Now when I graph it. Now that looks like what's on your paper. Okay, so the blue one going up starts here and goes up, and then the red one starts here. So let's take a look at the values that we have. The blue one started, because it's the y-intercept, started at 20.64, which is about here, and went up like this. And then the red one started at 0 and went up like this. Something like that. Okay, so the blue one is y equals 0.18w plus 20.64. And the red one is y equals 0.26w. Okay, so there is my graph. All right, so that's a quick review of graphing them. So use your calculator's intercept command to determine the number of widgets W that must be produced for the revenue to equal the cost. Basically, we're looking for where they intersect. We are looking for this point right here. We are going to have the calculator calculate that for us. All right, let's see if we remember how to do that. You would press second, the trace key. We're looking for the intersect, so I want number 5. All right, and this is asking me, it's on the blue graph. Is that the one I want to use? Yes. Enter. Then it jumps to the red graph. Is that the one I want to use? Yes. Am I sure? Yes. Press enter one more time. So I get the intersection of 258 and y is 67.08. So if that's 258 and y equals 67.08, there we go. That's my intersection point. All right, so basically what this is saying is at 258 widgets, the revenue and cost are equal. And they would be $67.08. All right, so if the profit is defined as the revenue minus the cost, so the profit is equal to the revenue minus the cost. Create an equation in terms of W for the profit. All right, so we said the revenue was 0.26W minus the cost. Now this is 0.18W plus 2064, so I have to subtract that entire thing. 0.18W plus 20.64. Okay, see if you can simplify this, and we will graph it in class tomorrow.